In the preceding examples, I demonstrated that you can increase the amount of work you could extract from a process if you operate the process very slowly and increase the number of steps involved to infinity. And so what I want to do in this video is basically summarize all the main points about what exactly a reversible process is. Okay? And so a reversible process or reversible path is a process in which the maximum possible amount of work is obtained. Okay? Right? And so like we saw in that pressure versus volume diagram, in that forward process, you want the process in which the entire area underneath the PV curve is taken up. Okay? And so in order to do this, right, if we're talking about expansion, during each stage of the expansion, what needs to happen is that the forces driving the expansion of the gas, so basically the difference between the force of the gas and the force acting in the downward direction, have to be very tiny. In fact, they have to be infinitesimally unbalanced. So that means they're basically the same. Okay? Okay? And so then that means, for expansion to occur, the differences in the pressure or the differences in the temperature that drive the expansion had to be so small that they become essentially continuous derivatives. So they become a derivative of pressure or derivative of temperature. And this occurs as the number of steps in that expansion increases to infinity, or if you're just thinking about the example in terms of like grains of sand that you remove from the top, the differences in the grains of sand or the mass of the force acting against the gas has to go to zero as well. Because these steps are so tiny, the changes in the system are also very tiny. That means that the system never leaves equilibrium. Okay? And so because the system never leaves equilibrium, that allows us to use our thermodynamic models to describe different properties, such as pressure, volume, or temperature. So thermodynamic models can describe PVT. Okay? But I do want to point out, while it does sound like, it's obviously a good idea if we can max out the amount of work we obtain from a process. But in order to do this, really, this whole idea is kind of just a hypothetical thing. And so the reversible process is just an idealized mathematical limit. And in order to achieve or perform a reversible process and extract that maximum amount of work, it's going to take an infinite amount of time to do that. Okay? And so while reversible processes allow you to extract as much work as possible from your system, they're not practical, right? You can't actually perform them. And that's because in real life, or one consequence of that, is that for all the processes we deal in real life, they're not reversible. And in fact, they're going to be very irreversible. Okay? Right? And so just to kind of restate this again, all the processes we deal in life are going to be irreversible, and we're not going to be able to actually obtain the maximum possible amount of work from our system. But it is still very useful to think about reversible processes, right? Because by identifying what the reversible process would be, that allows us to calculate a hypothetical upper limit for the energy that's available to be transferred from our system. Okay, and so calculating work for the reversible process provides a hypothetical upper limit for energy available. Okay. Right? And if we compare the ratio, or we take a ratio of the work exerted by an actual process, an irreversible process, and divided by the amount of work we would get from a reversible process, that would give us the efficiency of our irreversible process. So whenever we say how efficient is a process, that's what we're talking about. We're comparing the irreversible path to the reversible path. Okay. Now, the last thing I want to bring up is, you have a system, and the maximum amount of work available from that system, that's based on, the amount of energy that's in your system, right? That's what the work is characterizing. Okay? And so if we kind of think about the first law of thermodynamics again, if energy is conserved and the reversible work is essentially the maximum amount of, or the hypothetical amount of energy that's available to be transferred from your system. So is the hypothetical max energy available. Whenever we undergo a irreversible process, we're essentially not using all the energy that's available in our system. Okay? And so that begs the question, if we're not being 100% efficient, and we're not using all the energy available from our system, where's all that extra energy going? So where is the unused energy from the irreversible processes go? Okay. All right, so that's kind of what we need to think about now, right? If we're not using all the energy available in our system, what's happening to it?